The next question is calculating the integral of 2 over pi sine x minus 2 cosecant squared of x dx. To calculate this integral, you can break it down into smaller pieces. This is the integral of 2 over pi sine x dx minus the integral of 2 cosecant squared of x dx. First of all, this is just a coefficient. You can take this coefficient and write it in front of your integral. Sine x dx minus another coefficient that you have, which is 2, the integral of cosecant squared of x dx. So remember that when you have the integral of sine of u du is equal to negative cosine u plus constant of integration. But how do we calculate the integral of cosecant squared, right? Cosecant squared of x dx. This guy in turns is equal to the integral of 1 over sine x to the second power dx. How do you suggest to calculate this integral? What's the best way to calculate this integral? What substitution helps you to do the calculation? This integral in turns is equal to negative cotangent of x plus constant of integration. We're basically taking the derivative of cotangent, and the derivative of cotangent with a negative sign in front of it is equal to 1 over sine squared of x, or cosecant squared of x. These are antiderivative shortcuts that you learned before, and the proof is also available. So this can be written as negative 2 over pi of cosine x. And since you have a negative sign, you get plus 2 cotangent of x plus constant of integration. Next example is talking about the inverse sign, right? So remember that if you have the inverse sign of x and you take the derivative of inverse sign, this is 1 divided by square root of 1 minus x squared. Now, if I ask you to calculate the integral of dx divided by square root of 1 minus x squared, we're going to quickly say that it is equal to the inverse sine of x plus constant of integration. Now we're going to use these and calculate the following integral. So now I ask you to calculate the integral of, let me copy down the question, 4 divided by 3 times square root of 1 minus x squared minus 3 divided by x dx, right? First of all, you can just separate this into 2 integrals. The integral of 4 dx divided by 3 times square root of 1 minus x squared minus the integral of 3 dx divided by x. Well, The first integral, we already know if you have the integral of dx divided by square root of 1 minus x squared, it is equal to the inverse sine of x, right? But here you have the coefficient 4 divided by 3 that you can write in front of your integral. So this can be written as 4 over 3, the integral of dx divided by square root of 1 minus x squared, minus 3 integral of dx divided by x. But this integral is the inverse sine function, right? So you get 4/3 inverse sine of x minus 3, and the integral of dx, or in general du, divided by u is equal to ln of absolute value of u plus constant of integration. If u is positive, you can get rid of the absolute value sum, but in general, this is -3 ln of absolute value of x plus constant of integration. So that's how we use the shortcuts that we learned in antiderivative section.